In this video, I'll be describing the chain rule, product rule, and quotient rule, which are all three different methods of differentiation, each used depending on the function. The chain rule is the method of finding the derivative of a composite function, for example, when one function lies within the other. An example of this would be y equals log natural x squared plus 2. Here, log natural is a function as well as the inside bracket. In which case, we can set u equal to x squared plus 2, and y now becomes log natural of u. The chain rule states that dy by dx, the derivative, is equal to dy with respect to du multiplied by du with respect to dx. These variables are interchangeable depending on the equation that you're using. So now I just need to find dy du and du dx. Fortunately, I've written out them in these two separate equations here. So if I take the derivative of the first equation with respect to x, I get 2x. And the derivative of the second equation is 1 over u. From the equation here, we can see that dy by dx is equal to 2x multiplied by 1 over u, which becomes 2x over u. If we substitute u back into our final formula, then we have 2x over x squared plus 2. This equation is the most important part of the chain rule to remember. The product rule is taking the derivative when an equation is the function of two products. For example, if y equals uv, where u and v are functions of x, then we have to take the product rule into account. The product rule states that the derivative equals v multiplied by du by dx, and then you add u multiplied by dv by dx. An example of this will be y equals x squared minus 2 e to the x. If we see that we multiply this out, we would have x squared multiplied by e to the x, which is a product of two functions of x, in which case we have to now use the product rule. So if I set u equal to x squared minus 2 and v equal to e to the x, then I can begin the process. I take the derivative of each of these with respect to x. From here, I now have all the necessary components to plug back into my original equation. So if I take e to the x multiplied by 2x and add x squared minus 2 multiplied by e to the x, then I have my final equation for the derivative of my original formula. The quotient rule is the derivative of a function that is a quotient of two other functions. i.e., if you get an equation in the form like this, where the function of x is divided by another function of x, then you have to use the quotient rule. The general case is when y equals u over v, where u and v are again both functions of x. The quotient rule is as follows. The derivative of y with respect to x is equal to v multiplied by du by dx, take away u dv by dx over v squared. This is very similar to the product rule, although notice there is a negative sign here. Again, we're going to set the top of my example to u and the bottom to v. Similar to the product rule, I now have to differentiate each of these. Dropping the power on the x squared, I get 2x, and differentiating the exponential function with power for x is itself. All that's left to do now is to put it back into our original equation. So v is e to the x, multiplied by du dx, x squared plus 1, take away x squared, v is e to the x, du by dx is 2x. We take away x squared plus 1 and multiply this by e to the x, as both v and its derivative are itself. I then divide this by v squared, which is e to the x. E to the x squared is equivalent to e to the power of 2x. So the bottom of this equation will read e to 2x. This is equal to the derivative of my example.